Yeah, that's sort of what I thought you would say. Anybody else? I hope that the movie did make clear for you the basics of the pickle. And I also hope that you can see that there's really like no obvious cheap answers. Like it is really like a pretty tough crux to crack. Okay. Take out your 8.5 and Naomi will come stamp them. Also take out your 8.2. I think we're going to get into that today. 8.5 is 37 to 55 or something. Is that right?
18 questions.
18 questions. Those are the reading packet questions?
Yeah.
Cool. Here comes Naomi to stamp your 8.5. While she's doing that, let's get going with 8.2.
Some of those words I didn't get from the picture.
Step over the name. So we should. That's right. I think everybody remembers why wetlands are so important. If not, you might want to put this thing on a list. I've got 6 reasons on my list of why wetlands are so important. Most of this is pretty straightforward. Like wetlands help recharge groundwater, number 1. Number 2, the nursery effect. You know, a place for the bugs to breed, so it's a place for the birds to eat, the fish that are all breeding there. Number 3, bioremediation. Wetlands improve water quality. Number 4, coastal wetlands provide a buffer against storm surges. Yes?
For 8.3?
Yeah. I'm on number 21. Is that 2 or 3?
That's 2.
Number 5, I think you've already heard this word, the sponge effect. And if you don't remember the sponge effect, like a sponge left in the drain of your sink, a wetland absorbs and slows floodwater, then gradually re-releases that downriver. So they extend and moderate the surface flow. Finally, number 6, the last reason that we like wetlands. You probably understand why, but you haven't heard this in my class before. Wetlands are a critical carbon sink. Because so much organic material deposits in wetlands, wetlands are a place where we hide organic carbon, and much of that turns into rock. Don't forget, most of our fossil fuels started as carbon deposit in a wetland. Yeah.
What was the store?
The protection provided by coastal
From storms and such.
So you've seen photos of wetlands. I don't need to add too many. You can imagine, in some places this is at the bottom of a river. In some places it's in the headwaters of a river. Some wetlands are in the floodplain or peripheral to a river. Yes.
To deal with prairie holes. I mean, yeah, you would exactly heard it. Prairie holes? You know what I'm talking about? Oh, this is in the book. Came up. They're apparently just wetlands in the middle of the prairie, just random kind of holes.
Yeah, so that would just be any place where you have a natural depression, a concavity. You know, valleys with a little tiny bit of uplift will create like a bowl. I'll show you a photograph of what I guess are prairie holes. Like that?
Yeah.
The reason I end on this photograph is because, like you see in the picture, wetlands make for really good farms. Wetlands are usually pretty flat. They usually have really fine soil. And what's wrong with the cell phone? You did it. What? You did it. Yes, is what I'm saying. They're flat, they have high water table, their soil is high in nutrients. Great place to have a farm. Unfortunately, we're running out of wetlands, and now we realize, oh dang, there's all those reasons, 1 through 6, that we wanted wetlands in the first place. As a matter of fact, we had these wetlands that are ecologically awesome. We replaced them with farms, which are really good for civilization. But without wetlands and having all those farms, we started getting all this water pollution. So now we add artificial wetlands to the farms, which used to be wetlands in the first place. So what you see there is real wetlands that's been paved over to make farms in the foreground, but maybe in here or in there would be a good place to put an artificial wetland to filter the runoff of the farm before it hits natural bodies of water. One of the best chances for you to get a job when you get out of college, if you want to work in environmental science, is building bioswales. You guys remember what those are? Man-made wetlands, artificial wetlands that we use to clean up water? The bottom line of this class is, dang it, I wish I had known that earlier. That's like environmental science distilled to its purest essence. Dope. So our big dope moment is we didn't realize how critically important wetlands were. We paid them all over to make them into farms, and now you can all get jobs rebuilding or restoring wetlands. Pretty good work, by the way. It's like a lot of outside time, work with living things, relatively decent pay. I know people that are making a decent living with wetland restoration. All right. Anybody want to talk more about wetlands? Because what I really want to talk about. What I really want to talk about is dams versus rivers. A lot of my students are kind of curious, like how the dam gets there in the first place. So I've put together this slideshow just to satisfy the curiosity of the students who are coincidentally curious. We got to make one of those, which, as you can see, is a plug in a river with an intake. some plumbing that shoots the water past the turbine that generates electricity for the grid before the water is returned to the river. On the screen, the water is flowing from your left to your right. So on the way down the river, it fills up the reservoir, and then the leftovers spill out. I don't know if it's an obvious challenge, but do you guys realize that the bottom of a river always has water in it? And it's not really easy to build if there's water like moving through your feet. So the first step is you have to actually divert the river.
That's a good question.
Yeah, bro.
Do a lot of fish and stuff get stuck through the, like, how do they prevent that? Do they just put a screen on it? Because then wouldn't they just get stuck onto the screen and stuck there, and then that was dead fish there?
So, probably, yes, they do get sucked through the turbines. There may be other ways to let the fish out. So you could have like a low flow excluder device.
Yeah, they have that in the movie.
Before it speeds up to go through the turbines. There may be a way to discourage the fish, like making light or artificial alligators or something. I don't know. But I do believe that fish in the plumbing is a common problem. I know for a lot of fish, they do get masticated by dams, but like on the Columbia River, that's a really big deal.
That seems like it's just a really big blender.
Yeah, it pretty much is just that. And it's a super high pressure blender too. The water that comes shooting out of the reservoir after the blender is at like thousands of PSI. So even if the fish made it through the blender part, then it's like fired out of a cannon before it hits the river again. And so I would think that there are many other perils. It is a migration fraught with peril. So check this out. The wavy blue stuff is the original footprint of the river from up here to down there. And these are called diversion tunnels. You can see the red diversion tunnel there. This fingernail thing is the dam. The light blue is the footprint of the reservoir, the surface of the reservoir. These little circles are the intake towers. Those spill water from the reservoir into this plumbing. This plumbing shoots the water past the turbines before they return the flow to the river. But before you can build any of this, you gotta have these yellow diversion tunnels in place so that they create a dry bottom. So this is the tunnel, and there it is being filled with concrete. Essentially, if water is flowing from Jack to the whiteboard, we need to start at the upriver side of our construction site, make a hole in the canyon, and we will burrow through the wall of the canyon. This is me burrowing through the hole. And then we pop out on the downhill side of the canyon. From above, we drop in rocks, and that raises the level of the water back there, so it spills into the diversion tunnel, and all of a sudden I'm standing on wet ground. So these are the diversion tunnels. Here's the place where the water goes into the tunnels. You can see the dry spot on the bottom of the river. Here's that earthen dam. So this water is overflowing into tunnels that are on the right side that goes through that canyon. And you can tell that's at a slightly lower level down canyon there, right? Then in that dry space, we make a big pile of dirt. And up against the pile of dirt, we start making a pile of concrete. stack up more concrete, stack up more concrete. I just fast forwarded through like 10 years of construction. There's a lot of really fancy engineering about which